Welcome to Spring LIB.
Hi everybody, so we're seeing which of these is possible, which of these reactions is possible. So let's start with A, and we're getting pion negative plus proton. Here we have cation plus the sigma bayon. Okay, and here we need to find the conserved charge, and I'm writing the conserved charge as charge. So we're going to write that as CC from now on. Okay, we can find this information, the numbers from your appendix, okay? So, yeah, 1 here, -1 plus +1 on this side. The other side is +1 plus -1. So that's going to be 0 to 0. Okay. Next, we're going to look at Veyron conserved. We'll call it BC. And it looks like we have 0 plus +1 on one side and 0 plus +1 on the other side. So we get 1, 1. So that checks out. Oops, how do I write that? That checks out. Okay, now we need to look at the strange. Okay, so the strange is going to be CS for strange. And it looks like we have 0 plus 0 plus 1 minus 1, actually. We'll do this. There we go. Okay, so it's going to be 0 to 0. So that checks out. So this means that it is possible. And it's strong because of the boron. Okay? Now let's do the second reaction. So the second reaction is pion plus proton plus the cation plus the sigma boron. Okay. And I write my pi's like this, so it's supposed to be like that, okay? Just in case if you're curious. So let's find the CC, the conserved charge of this. And we have 1 on this side and 1 here. And it looks like this is also +1 plus +1. So that means there's 2 and 2. So that checks out. Okay, so let's find the BC, the boron. Okay. So now we have 0 plus 1, because it's a positive, and 0 plus 1, positive. So 1, 2, 1, which is good. Now we need to find the strange. Okay. It's just fun to say strange. Okay, so -1 plus 0 on that side, and the other side is -1 plus 0. So we have -1 to -1, so that checks out. So that means this is possible and strong. And it's strong, like I said before, to the boron, okay? Now for C. Okay, so C was given to us as pion plus proton plus the lambda boron knot, okay, plus the cation knot. Cation knot is called a meson, by the way. And there we go. Okay, so we find the conserved charge. And it looks like if you conserve charge, we have a negative, oops, get back to black there, -1, +1, to 0 plus 0 plus 0. It's going to be 0 to 0. Okay. And now we have the CB. Okay. And it's going to be 0 plus 1 to 1 plus 0 plus 0. It's going to be 1 to 1. So that checks out. Let me bring it down a little bit. And now we have the strange. And that's going to be 0 plus 0, negative 1 plus 1 plus 0. And that's going to be 0 to 0. So that checks out. So this is possible. And it's a strong reaction. So we get strong. Again, that's due to this. Okay. So now we have D. We have a pion, proton, plus the sigma baron, not, okay, plus the pion, not. And now we need to find the CC, conserved charge, and here we have plus 1, plus 1, 0, plus 0, plus 0. And we can obviously tell that's going to be 2 to 0. So this does not work. So this is, oops. So this is not conserved. So it's forbidden. Isn't forbidden just fun to say? Okay, so now for the last one, which is E. And we have pion plus proton. Okay? Proton plus the electron plus the electron neutrino. Okay? Now we can do conserved charge. And looks like we have negative 1 plus 1, 1 plus 1 plus 0. Oops, negative 1. There we go. So we have 0, 0. So that checks out. Now we have the BC. And that's going to be 0 plus 1, 1 plus 0 plus 0. So it's 1 to 1. So again, that checks out. The next one is going to be the C of the lepton. So here we have 0 plus 0. Okay, and oops, and we do the conservative lepton because there's a lepton particle in here. Okay, if you're just curious. Just negative 1. 0 to 0. Check out. Now we need to find the strange. Okay, so it's going to be 0 plus 0. 0 plus 0 plus 0. So 0 to 0. Checks out. And this is going to be conserved. But it's going to be weak. And it's weak because of the lepton. It's weak because of the lepton, okay? Thank you guys so much.